All right, this is the first free response problem on review day 10. We have a table of values that tells us how much grain is being added to a silo in the first, appears 8 minutes that they've been adding it. And the silo is empty to start with, and the rate that it's being added is given to us here. So A, approximate G prime of 3 and explain what it means. So again, here's their you see it almost every time with these table problems. They want you to approximate something. So we're going to go 20.5 minus 15.1 over 5 minus 1. And you could use your calculator for this. So hopefully you don't make a silly mistake here. And we should get 1.35 for our answer. If you have that as your approximation, that was a point. Now we have to talk about what that means. So the rate that the grain is being added is increasing at a rate of 1.35 cubic feet per minute, or per minute squared, whichever way your preference is. So if you have that interpretation with the correct units, that's worth another point. So it's the rate that the rate is changing, right? If you're just general and say the rate that the rate, you might get away with it, but they kind of like it when you talk about what it is that's happening in the problem. All right. B, write an integral expression that represents the total amount of grain added from 0 to 8. So that's super easy. We're just going 0. I mean, they basically tell you, write an integral. So 0 to 8 g of t dt, that's your integral. If you have that, give yourself a point. Okay, now we're using a right-hand Riemann sum to approximate it. So we're going to say this is approximately. Now, if you needed to see this, by all means, you could draw a picture and, kind of say, all right, from 0 to 1, we're going to use the 1 side. So we're going to use 15.1 here. From 1 to 5, we're going to use the 5 side, and that's 20.5. From 5 to 6, we'll use the 6. And from 6 to 8, we're going to use the 8. And it just helps you visualize it a little better, but you want to write out then here what it is that you're multiplying. So we're going to be doing 15.1 times the distance between them, which is 1, plus 20.5 times the distance between them, plus 18.3 times the distance between them, plus 22.7 times the distance between them. Throw that all on your calculator and you get 160.8. They gave us a point if you showed that you were using right hand, and a point for having the right answer. Pretty generous. All right, didn't have to have any units there or anything, so no worries on that. C says the grain is in the silo is spoiling at a rate of this. So this is how much it's spoiling or leaving, right? Where WT is measured in cubic feet. Use the result from B, approximate the amount of unspoiled grain. So this is one of your total amounts. So what we normally do is grab the initial amount, but it was empty to start with, so we don't have to worry about that. What we're going to do is take the grain that was added in, which is 160.8 cubic feet, minus the rate that it was leaving or spoiling. So 160.8, our answer from B, minus how much it spoiled. And I believe if you do that correctly, you'll get 61.749 cubic feet. Okay, they gave a point for having that integral on your paper and a point for having that answer there. Okay. And then D, based on the model in part C, is the amount of unspoiled grain in the silo increasing or decreasing. So we know the rate that it's increasing at 6. The rate that it's increasing is G of 6, which is 18.3. Okay. We can find the rate that it's spoiling. That's W of 6. So I put 6 into W and calculate, and you get 16.063. So the amount of unspoiled grain is increasing because G of 6 is greater than W of 6. If you feel like explaining it a little bit more, you can, but that's enough to give you a point and a point for describing the increase.